So in this video, we're going to take a look at insecure data storage. So there's a lot of different ways to try to store data in Android applications, and a lot of them may appear secure on the surface. However, with the proper permissions and setups, you will be able to gain access to them as someone who is not supposed to gain access to them, which in turn can mean that you can compromise sensitive data either from the user or from the developers themselves. So this is sort of like a two-sided vulnerability. In sense of like getting user data, it's a bit of a weaker vulnerability because it requires root access to be able to access most of these files. There may be ways, however, to get access to these files without root permissions, and that would be an indication of a vulnerability. However, if there's specific like developer secret data inside of these files and we're able to access them, then this would be a vulnerability whether or not we have root access, because we shouldn't be able to get access to those sort of secret data pieces such as API keys and passwords and that sort of good stuff. So in this video, we'll take a look at a few different types of vulnerabilities like this. So the first one is the insecure data storage part 1. With this, we can enter in, say, a username and a password, and we can save it onto our device. So we enter in the username and password, and then we hit save, and it will say third-party credentials saved successfully. When we take a look at the code for this, we can see that when we save the credentials, it's using what's called a shared preference. Now with shared preferences, they're essentially specific types of files that exist in a standard directory, and these files will be able to store different pieces of information in them. And the idea is that when we're trying to access data, we can access it from a known location that is sort of local to the application and not accessible unless you have root permissions. This works very well for trying to store data that isn't sensitive. So I don't know, just like data that's generally used by the application, maybe like locations of images or like a set of questions for like a survey or something like that. These sort of things wouldn't be sensitive because they're accessible by the user through the application. However, if we can access something that isn't accessible to the user through the application, this would be an instance of information disclosure. So how do we gain access to these shared preferences folder? What I'm going to do is I'm going to go ahead and shell into my device. And when I shell into my device, I'm going to go ahead and make myself a super user using the su command. And then what we're going to do is we're going to cd into the data folder. And then inside of here, there's another data folder. So we're in data/data. And inside of here, you'll see data for all of the applications that are on your device. So all of these applications have data associated with them. This one right here is the folder associated with Diva. The name will always match the name of the application itself. So we can cd into that folder. And you'll see inside of here we have a few different options. We have the cache, we have the code cache, we have databases, we have the libraries, and then we have our shared preferences. The shared preferences is where we save all the data that's written using this shared preferences object, right? So anytime that we do this, we're going to be saving into that shared preferences folder. So now if I cd into shared preferences, you'll see that we have this single XML file. And if I use the cat command, I can see what's inside of that file. I mean, alternatively, you could also pull it off the device and read it, but the cat command allows you to see it quickly. And as you can see, it stores the username and password that we typed in. So whatever we type in inside of there will be what's stored here. So for instance, if I change this to password 1, for instance, and save it, then we should see that this will change to password 1, which you can see right here. So you can see that this would be considered insecure data storage because I can gain access to it just by having a rooted device. The fact that I have a rooted device is sort of irrelevant to my ability to access this data. I shouldn't be able to get usernames and passwords whether I'm rooted or not. So this would be an example of insecure data storage. Right, and then you can go into like the other pieces, like, you know, the password really should be hashed or something like that. In this sense, it really doesn't matter if it's hashed or not, because you can offline brute force that password and potentially gain access to it, and you'd know how it's hashed based on the code. Since we have access to the code, we have access to the password hash. Therefore, unhashing the password or finding the hash that corresponds to that password wouldn't necessarily be hard, unless the password's extremely long. But there are certain instances where it could be like a weak password, we might be able to compromise it and gain access. So this is something to note about these shared access points, is that they are accessible by root users. So we really should be favoring things like online servers if we can, or sort of hardening these down, like password protecting the files or password protecting a database, for instance. And speaking of databases, we could take a look at database storage as well. So let's go ahead and I'll go back here. and we have a second insecure data storage. So in this one, again, I can put in like username and password. And again, when I do this, I can save it and it will save it successfully. So if we take a look at the code here, you can see that we're inserting the data into a SQLite database, right? So in general, most databases that you work with through Android are going to be SQLite, but you can also tell that because of the import up here that says SQLite database that exposes what kind of database is being used. So you can see that this information is being saved to some sort of database. Then we can ask, well, where can we find that database, right? And the answer is, if we see the up1 directory, we'll see this folder called databases. If we go into the databases folder, we can see that there's a bunch of different databases that exist inside of here. Now, we want to determine which of these databases is the correct one. And we really just have to sort of look at the different things that are available here. You'll see open or create database, IDs2. This tells us that the IDs2 database is the one that we're likely looking for. So what I can do is I can say SQLite 3 IDs2. And as you can see, this opens up the IDs2 database inside of SQLite. And then from here, you can type in a command like .tables, and that will show you the tables that exist in the database. And then we can do just like a simple select star from my user. And you can see it exposes any users that were inputted into this input field, right? So I did the test one earlier. Username and password was the one that I just did. So you can see that this very easily exposes the user. So again, since I can access this data, it isn't considered to be a secure data storage method, because even though I have root access, it doesn't really mean much if I can access the data still. You know, whether you can access it with root, whether you can access it without root, you're still able to access sensitive data, which you shouldn't be able to do. So this is something that we need to consider as well, is that these databases, if they aren't properly secured, could be compromised. The proper thing to do here is to use a library. There are a few like SQL Cypher, for instance, I think is one that's available for Android. And what they'll do is they'll password protect these databases for you through like an encrypted process. So anytime that we need to access it, it needs to sort of like decrypt it and then run our queries and then encrypt it again. So if this is done, then if we try to access it through the SQLite 3 command, we won't be able to. We'd have to actually crack the encryption on the database. And if that encryption is sufficiently strong, then it would be a much more secure data storage than just storing stuff in plain text out in the open, right? So this is another thing to consider. And this is even before we consider the fact that it looks like this could easily be like a victimize of SQL injection, right? You could probably do SQL injection because we're just concatenating stuff into it, but that will be something for another lesson. Anyhow, yeah, so this would be another example of some insecure data storage, is if we store things in the databases that are available to us, a rooted user can still gain access to them and potentially get to those credentials. Now, the third type of insecure data storage is sort of like a more generic type of insecure storage. Again, it's the same sort of structure where we have username and we have password. And again, we can save it and get the credentials saved successfully. And if we take a look at this, really all this does is it creates a temp file. You see it has uinfo in front of it, and it sets it to readable and writable, and then it writes in the username and password and saves it. So when this sort of thing happens, we're essentially saving it local to that data folder. And you can tell that because, so it's get application info.datadir. Datadir is this data directory that we're currently inside of. So when we do this, you'll be able to see that I can, let's quit out of SQLite. And if I cd up1 directory, you'll see this uinfo temp folder that's now been created. And again, I can simply just cat that folder and you'll get username and password, right? So you can see that it, again, just saves the data in plain text. Even though it's in a directory that can only be accessible by root, the data is still there and accessible, so you can still gain access to it. So this gives you a good idea of the different types of insecure data storage that exists. So in general, if you're looking at any sensitive data that is stored inside of databases and sort of shared preferences or just inside of temp folders anywhere, a root user can gain access to them. So those folders should be treated with the same level of security that someone is able to access them if they so choose to. So you have to keep that in mind and work with things like encrypted files or encrypted databases in order to ensure that people can't actually access this data, because leaving it out in the open means that if you have a rooted user who's using your application, they can gain access to that data, which could potentially be catastrophic depending on what kind of data is accessible there, right? If it's just their username and password, it's not really that big of a deal. But if it's other people's usernames or passwords, or generic information about like the application, application usernames and passwords, admin usernames or passwords, any of that sort of stuff, then we don't want that to be stored here, because then you can gain access to it. So this gives you an idea of what to look for these sort of things. Again, when you decompile the application, you can look at things like shared preferences and file rights and database inserts to find these sorts of vulnerabilities. Or in general, you can just sort of use the app a little bit and then go to its data directory and see what kind of stuff is available inside of there. So these are some common vulnerabilities that will typically exist inside of Android applications that you are now able to find and report if you find them.